Question 1 comes in two parts. The first part tells us that this curve, y is equal to ax squared plus bx, has a gradient of 4 at x equals to 1 and 14 at x equals to 2. From that we're asked to calculate the values of a and b. So how do we know what the gradient is? We're going to find the gradient at a point is the same as dy by dx at that point. So this 4 is actually the same thing as dy dx at x equals to 1, and this 14 is the same thing as dy dx at x equals to 2. So let's work this out. Our initial equation, y is equal to ax squared plus bx. So dy dx, differentiate this with respect to x, we get 2ax plus b. And we know dy by dx at x equals to 1 is going to be 4 from our original equation, gradient of 4 at x equals to 1. So, but this is also equal to, and we can substitute 1 in here, so this is going to be 2a plus b. So we get an equation that we can solve. We also know that dy by dx, when measured at x equals to 2, is equal to 14. So 14 is going to be equal to, and just substitute 2 in here, you get 4a plus b. So now, this is our second equation. So now we can solve these. So we see that there's a common b term in both, so I'm going to say, what is my second equation minus my first? And that's going to give me, first of all, 14 minus 4 is going to give me 10, is equal to 4a minus 2a, which will leave me with 2a, plus b minus b, 0b. So a will equal to 5, just rearranging. Then we substitute a equals to 5 into the first equation. What do we get? We get 4 is equal to 2 times 5 plus b, which means b is equal to, which means that 4 is equal to 10 plus b, so b is equal to negative 6. So we've finished part A now. What is part B? Part B says that the gradient of this curve at this point is 3. Now calculate the values of P and Q. So from this we're actually going to get two pieces of information. Firstly, we can just substitute this point, 1, 9, into this equation. So we know x equals to 1, y equals to 9. The second thing is we know the gradient is 3. So we know dy by dx at x equals to 1 will be 3. So we can use this again to solve our solve for p and q. So again we have y equals to px plus q over x squared. So this is the same thing as px plus q x to the negative 2. So the first thing we can do is we can substitute in the point 1, 9 into this equation, and what do we get? We get 9 is equal to p times 1, so p, plus q divided by 1 squared, so q. So this will be our first equation. Our second equation, we need to find dy by dx, which is easy enough, so I don't need that line just yet. Need to find dy by dx, so we differentiate this, so differentiate px, you get p, then differentiate qx to the negative 2, the negative 2 comes down to the front, and you get q to the negative 3. So specifically dy by dx at x equals to 1, well, from our question we know that the gradient is 3 when x equals to 1. So this will equal to 3. So we can say 3 is equal to, and we just substitute, sorry, I made a mistake up here. This shouldn't be q to the negative 3. This should be qx to the negative 3. So we just substitute 1 into this expression and we get p minus 2q. And this will form our second equation. So now we have to solve these simultaneously. And we can do this easily enough just by subtracting one from the other. So we notice there's 1p here, 1p here. So I'm going to say 1, the first equation, minus the second equation. What do I get? I get 9 minus 3, which gives me 6, is equal to p minus p, so 0p, and then q minus negative 2q, so it's plus 3q. So from this I get that q will equal to 2. So I'm not finished yet. Sub q equals to 2 into, say, the first equation. What will we get? We'll get 2 is equal to p plus 2. What am I talking about? Not 2, 9, sorry, here. 9 is equal to p plus 2, so 7 is equal to p. And now we've found our values for p and for q. And we have finished part A and part B.